As always, solving equations or systems of equations is so much more fun when you have to derive the equations yourself instead of having a textbook or somebody else just plop them into your lap. So here's a little scenario that will let us do that. So we're told that the difference, and wow, that handwriting is bad. The E-R-E-N-C-E, okay, whatever. The difference between two positive numbers is 42. The larger number is 2 more than 6 times the smaller number. What are these two numbers? Since we are seeking values of two unknowns, we need to have two equations, and there is enough information here to produce them. But first, as always, we identify the unknowns that we're working with. So we'll say let's just use x and y so we don't strain ourselves. We'll let x be the smaller number, and then y can be the larger number. So we've now named our unknowns, and it's important to do this because there are some subtleties here that you really need to track. So the first subtlety, let's break down this phrase. The difference between two positive numbers is 42. Now, difference means we're going to subtract them. That can be interpreted either this way or this way. There's two ways to write the difference, and we have to pick which one we want. And so this is where the details are important. We've designated x to be the smaller of the two numbers, and y is the larger. If x is smaller than y, then x minus y needs to be a negative number. This particular expression doesn't do that for us. So here we have the larger minus the smaller, and that is 42, which is a positive number, so this is consistent. All right, now, the second piece of information we have is that the larger number is 2 more than 6 times the smaller. So we've got a comparison between the larger number y and 6 times the smaller number, and the larger number needs to be 2 more than 6 times the smaller. So we need to take 6 times the smaller number and then go up by 2 more to get the larger number. And so the larger number is 2 more than 6 times the smaller. And so we can collect our two equations as y minus x equals 42 and y equals 6x plus 2. Now remember, in the last example we talked about how there's a consistent format that we like to have, and it doesn't matter really what the format is as long as you're always consistent. We have to have these variables, the constants, the equal signs, all lined up in the same place in both. And so this pretty standard form of this is ax plus by equals c. So we're going to rearrange these two equations so that they are in that format, which means we want the x term first. In the top equation, that's negative x, and then the y term, so we have a plus y equals 42. Now in the second one, we have to move this x term from the right side to the left side. So imagine us subtracting 6x from both sides. And we'd end up with this. We've just taken this and moved it to the left side by subtraction. Now these things are lined up and ready to go. We are ready to consider adding the two equations together in a way that will eliminate one of the two variables. Now, the way they're set up, no elimination will happen if we just add them the way they are. But let's imagine having multiplied this second equation on both sides by -1. So I'm going to reconstruct this system. Negative x plus y equals 42. And multiplying the second equation by -1, I will have 6x minus y equals -2. And now, when I add these two things together, the 6x and the negative x will give me a 5x. Y and negative y give me 0. 42 and -2 gives me 40. So 5x is 40, or x equals 8. And if x is equal to 8, then y will be 6 times 8 plus 2, or 48 plus 2 is 50. Like that. So x is 8, y is 50. Is that consistent? The difference between these two is 42. 50 minus 8 is 42, and the larger one is 2 more than 6 times the smaller. So if we take 6 times 8, which is 48, add 2 more, we get the bigger number. So these work. Now, I've done a terrible job at organization and presentation here. This is scratch work at this point. If this was my work as a participant in the class and I was going to hand this in, this is not the page I would hand in. Having successfully completed the problem, I would now go back and make this part in particular a heck of a lot nicer, and then I would write out a good concluding sentence. But since I've sort of used up all the room inside the view here, I'm going to stop.